Good day to one and all. I am Bharati, Assistant Professor, Department of Mathematics, Tiruthangal Nadar College. I give present the topic Transform Techniques, particularly Fourier Series. In Fourier Series, we discuss about the period 2 pi. I will take now here the interval 0 to 2 pi. The period 0, 2 pi. So this is the formula. If f of x, that is the function of x, is defined in the interval 0, 2 pi, then f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx, where the Fourier coefficients that are a0, an and bn. These are the expressions. So what is a0? Equal to 1 by pi integral 0 to 2 pi f of x dx, an equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So the a0, an and bn, these are called Fourier coefficients. So now we solve the sample problem. Find Fourier series for f of x equal to pi minus x by 2 whole square. The interval is 0 less than or equal to x less than or equal to 2 pi. So this is the question. All time the question is same as in the examination. Here also we ask. So given what is the function is here, pi minus x by 2 whole square by 4. Here interval is 0, 2 pi is given. So right now first I will write the formula. If f of x is defined in the interval 0, 2 pi, then the formula f of x is a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx, where a0 equal to 1 by pi integral 0 to 2 pi f of x dx, an is 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. We will first find out the values of a0, an and bn. We get to substituting here, we get the series that is called a Fourier series. So now we can find out first a0. So what is the a0? The formula 1 by pi integral 0 to 2 pi f of x dx. So what is the value of f of x in the interval 0, 2 pi in the question? Pi minus x by 2 whole square. So I can expand this pi minus x whole square by 4. So we can now integrate this value pi minus x whole square by 4. What is the constant here? 1 by pi, 1 by 4 is the constant. How do you say the constant? Here the variable is x. So otherwise x is the constant. So I will take 4 and pi taken outside, 1 by 4 pi. So I now integrate pi minus x whole square. What is the formula for integral ax plus b power n dx equal to ax plus b power n plus 1 by n plus 1 into 1 by a. This is the formula. So I can use this formula here. Pi minus x whole square, I will take integrate pi minus x whole cube by 3. I will here minus, here minus 3. Therefore pi minus x whole cube by minus 3. So lower limit 0 and then upper limit 2 pi. So now substituting the upper limit 2 pi here, pi minus 2 pi, that is minus pi whole cube. Minus pi whole cube is minus pi cube by 3. So 1 by 4 pi is taken outside. And the lower limit 0. So formula is minus. I will put on 0 here. Pi minus 0 whole cube by minus 3. That is pi cube by minus 3. Already minus. So minus into minus plus. Therefore pi cube by 3. So for pi cube by 3, again 2 terms, that called 2 pi cube by 3. After simplification, 1 by 4 pi into 2 pi cube by 3, we get finally pi square by 6. That is the value of a0. So therefore value of a0 is pi square by 6. So and then we can for a0 by 2 means pi square by 12. So we now first to find out a0. Now an 1 by pi integral 0 to 2 pi f of x cos nx dx. So we are saying f of x, what is the value of f of x in the question? Pi minus x whole square by 4 cos nx dx. Therefore, equal to 1 by pi integral 0 to 2 pi pi minus x whole square by 4 cos nx dx. Now, what we can use in simplification the integral by using the Bernoulli's formula. What about Bernoulli's formula? Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. So what about u dash, u double dash and u triple dash etc. These are all successive differentiations of u, and then v1, v2, v3 etc. What are these? Integration of v with respect to s in successive times. So we can use this concept here. So now, integral u dv. So I will take as constant is 4 taken outside. I will take as u as pi minus x whole square. Pi minus x whole square. Cos nx dx. I will take as u. This is dv. What about dv? Cos nx dx. I will take as dv. So dv. So I will integrate cos nx into inside. So integration of cos nx is sin nx by n. So I will come to the format u dv. So where u is pi minus x whole square and then v is sin nx by n. So we can using the formula. I will take as this is u, this is v. So uv first formula u is v is minus u dash v1. U dash means differentiation of this. So what about differentiation? 2 into pi minus x and then minus 1. Sin nx by n. You can integrate in this. Sin nx integrate minus cos nx by n. Again here is also n. Therefore minus cos nx by n square. So uv minus u dash v1 plus u dub v2. So what is, you can again differentiate minus 2. Pi minus x differentiate minus 1. Minus 2 into minus 1 plus 2. And then integration this cos nx. What about cos nx? Sin nx by n. So for minus sin nx by n into n square minus sin nx by n cube. So lower limit is 0 and then upper limit is 2 pi. We know the basic facts. What are the basic facts? Cos 0 is 1. Sin 0 is 0. Cos n pi is minus 1 power n. And then sin n pi is 0. So n is even integer. N is an integer. N is an integer. Cos 2n pi is 1 and then sin n 2n pi equal to 0. So these are the basic facts. So we can using these basic facts here. How do we go? So you can apply this is upper limit 2 pi and the lower limit is 0. Upper limit is 2 pi and the lower limit is 0. We can substitute here sin 2n pi upper limit, sin 0 lower limit. In this case, here upper limit is also 0 and the lower limit is 0. So I am cancelling here. The same procedure we can using here. So sin 2n pi is 0 and then sin 0 is 0. So upper value is 0 and lower value is 0. So I will cancel this term. So only remaining is term. So we can using here upper and lower limit. The value will be 9. So how do we do this? Minus 2 pi minus 2 pi minus cos 2n pi by n square. This is upper limit. And the lower limit we can using here substituting 0. Pi minus 0 minus cos n is 0. So we get the value 1 by 4 pi 2 pi by n square plus 2 pi by n square. These are all 2 times. Therefore 4 pi by n square. You can after simplification we get 1 by n square. Here an equal to 1 by n square. We can now find out bn. So what is the value of bn? Bn is the formula is 1 by pi integral 0 to 2 pi f of x sin nx dx. So the same the question here f of x is pi minus x whole square by 4 sin nx dx. So we can now solving this integral by the same Bernoulli's formula. So we can construct the Bernoulli's formula integral of u dv. So we can constant is 4 is taken outside. So for 1 by 4 pi integral 0 to 2 pi minus 6 whole square sin nx dx. Okay. So now here we can make it as a form as u dv. So I will take as u is pi minus 6 whole square. dv is sin nx dx. So I will take the formula dv. So I will integrate sin nx here, sin nx minus cos nx by n. So I will take here minus cos nx by n. So this is the format of integral u dv. So we can using the formula the same method as formula uv minus u dash v1 plus u double dash v2. So u v, okay. Next u dash the same. How do you differentiate here? 2 into pi minus 6 minus 1. Now integrating this minus sin nx by l square. Formula is plus u double dash v2. So you can differentiating this 2. You can integrating this cos nx by n cube. So lower limit is 0 and upper limit is 2 pi. We can substituting the basic fraction. Already said that cos 0 1, cos n pi minus 1 power n, cos 2n pi is 1. But sin 0 0, sin n pi 0, sin 2n pi is also 0. So we can using the basic facts of this here. We can apply this upper limit in sin nx. This term will be cancelled. So I will cut here. Here only 2 terms. We can using the upper limit. So 2 pi is the upper limit. Pi minus 2 pi, that is minus pi whole square. Minus pi whole square is minus pi square. Minus into minus plus. So pi square by n. Cos 2n pi is 1. So minus 1 by n pi square. We can use it here upper limit 2 pi, 2n pi is 1. Therefore 2 1 n cube. No, 2 n cube into 1. 2 by n cube. So you can using the lower limit 0. Pi minus 0 whole square minus cos 0 by n. We get the 1 by n pi square. We can substituting x is 0 here. 2 into 1 by n cube. Therefore these all terms are cancelled. Because of that minus 1 by n pi square plus 1 by n pi square plus 2 by n cube minus 2 by n cube. So alternative plus and minus, we can cancel all terms. We get the value 0. 1 by 4 pi into 0 is 0. Therefore bn value is 0. So we now find out a0, an and bn. We can substitute these values in the Fourier series formula of f of x. What is the Fourier series formula of f of x? So f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. We can substitute all these values here. Therefore a0 by 3 is pi square by 12, an is 1 by n square, but bn is 0. So total summation will become 0. The remaining 2 parts are here. So you can expand in these terms. After summation, you can expand in these terms. So pi square by 12 plus we can substituting n equal to 1. Put n equal to 1 here. 1 by 1 square cos 1x, that is cos x by x square plus summations in the, and putting n equal to 2 cos 2x by 2 square plus putting n equal to 3 cos 3x by 3 square plus etc. This is the Fourier series expansion for f of x equal to pi minus x by 2 whole square in the interval 0 less than or equal to x less than or equal to 2 pi. So to prove that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. equal to pi square by 12 in this same problem. So we can substituting x equal to pi. We get the value f of pi in this, and we can substituting f of pi is minus pi whole square. We can after simplification we get the same value. That means we can substituting x equal to pi here, x equal to pi here, x equal to pi here, x equal to pi here. So x equal to pi means cos pi minus 1 by 1 square, cos 2 pi plus 1 by 2 square, cos 3 pi minus 1 by 3 square. How do you say cos nx is minus 1 power n? Therefore cos 1x is minus 1 power 1, that is minus 1 by 1 square. Cos 2 pi, cos 2n pi is I always say as 1. So cos 2 pi is 1, therefore 1 by 2 square. Cos 3 pi, that is minus 1 power 3, that is minus 1 by 3 square. Therefore f of pi equal to pi square by 12 plus minus 1 by 1 square plus 1 by 2 square plus minus 1 by 3 square plus etc. How do you find out f of pi? We know that f of x equal to pi minus x by 2 whole square. Now I am using here pi minus x by 2 whole square. That is, we can substitute pi. Pi minus pi is 0. So this total will be 0. So therefore, we can offer simplification. That is, the minus term you can convert it here. That is plus term. The final answer is we get 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. equal to pi square by 12. This is the problem based on the Fourier series in the interval 0, pi. We now discussed about Fourier series. The period is same to pi, but that interval is minus pi to plus pi. Fourier series, period 2 pi same period, but the interval is, before we will see that 0, 2 pi. Now we will see that minus pi to plus pi. So what is this? The formula for minus pi, pi. If f of x is defined in the interval minus pi, pi, then f of x equal to n naught by 2 plus sigma n equal to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin nx, where a naught is 1 by pi integral minus pi to pi f of x dx plus an equal to 1 by pi integral minus pi to pi f of x cos nx dx, and then bn equal to 1 by pi integral minus pi to pi f of x sin nx dx. So in the interval 0, 2 pi, here the interval is minus pi, pi. The only difference is integral of the interval. In before sum I will using 0, 2 pi. Here I will using minus pi, pi. The formula is more or less same. The interval is only different. So in here, even case, the same interval minus pi, pi, f of x is even. So first, what do you know about the even function? What is even function? Okay, a function f of x is said to be even. How? F of minus x equal to f of x. F of minus x equal to f of x. We can say that f of x is an even function. So example, we will say that f of x equal to x square. I will take as an example f of x equal to x square. Put replacing x by minus x. So here also replacing x by minus x. Minus x whole square is x square. This x square is nothing but f of x. What is the, therefore f of minus x equal to f of x. Therefore the function f of x is even. So it's an example for f of x equal to x square is even. Suppose here the function is even function and then the interval is minus pi, pi. So the formula is, we can reduce only this. Here bn is 0. In general formula minus pi, pi, a naught, an, bn we can find out. Suppose the function is even, we can simplify the formula. What about bn is 0? Therefore formula is f of x equal to a naught by 2 plus sigma n equal to 1 to infinity an cos nx, where a naught is 2 by pi. In general formula I will put on 1 by pi minus pi, pi. But in even function we can start, this very important is 2 by pi integral 0 to pi f of x dx, the same as an equal to 2 by pi integral 0 to pi f of x cos nx dx. So suppose the same interval, the function is given in an odd function. What is the first odd function? What is the definition of odd function? F of minus x is minus f of x. F of minus x equal to minus f of x. Then we can say that f of x is odd function. So best example for that, f of x equal to sin x. We can replacing x by minus x. Therefore f of minus x, sin replaces sin minus x, sin of minus x is equal to the minus sin x, which is nothing but minus sin x is f of x minus f of x. Therefore f of minus x equal to minus f of x. The condition of odd function is satisfied. So f of x equal to sin x is odd function. So f of x is defined in the interval minus pi, pi, and the f of x is odd function particularly, then the formula is only containing the Fourier coefficients bn and nothing but a naught and an. Here what is about a naught and an are 0. Therefore, f of x equal to sigma n equal to infinity bn sin nx. So, bn is the same 2 by pi integral 0 to pi f of x sin nx dx. This is the three concept. I will say that minus pi comma pi interval. First is general concept. Suppose if it is even, odd, or neither even, neither odd, we can use the general formula. And then using the function is inter minus pi pi. Even function means, so function only containing a0 and an, bn will become 0. Now here f of x depending on inter minus pi comma pi, function is odd function. We can only bn, a0 and an are here 0. This is the formula. So minus 2 comma pi minus pi comma pi. We can take as a general formula problem. So apply the Fourier series for the function e power ax in minus pi comma pi. Here is the function is f of x equal to e power ax. E power ax is this function which is neither even nor odd, because the function does not satisfy f of x minus x equal to f of x, that is odd function definition, and also neither odd function, that is f of minus x equal to minus f of x is all does not satisfy this function. So it is neither even nor odd, so we can use only general formula. So what is the general formula? Just now before we will see that if f of x is defined in the interval minus pi comma pi, then f of x equal to n on pi 2 plus sigma n equal to 1 to infinity a n cos nx plus sigma n equal to 1 to infinity b n sin nx. The Fourier coefficients a naught is 1 by pi integral minus pi to pi f of x dx, a n is 1 by pi integral minus pi to pi f of x cos nx dx, and then b n equal to 1 by pi integral minus pi to pi f of x sin nx dx. In same 0, 2 by problem, we can solve the first the Fourier coefficients a naught, a n and b n here. So a naught equal to 1 by pi integral minus pi to pi f of x dx. Here in this problem f of x is e power ax. So we will now integrate e power ax. So e power ax means e power ax by a, that is a constant. This coefficient is constant a. So I will take in the substitution minus pi. So lower limit is minus pi, upper limit is pi. We can substitute in upper limit pi, e power a pi by a. Formula is minus. We can use in the lower limit minus pi, e power minus a pi by a. So a will take an LCM a. This is a is constant. So I will take an outside 1 by a pi, e power a pi minus e power a pi. We know that formula sin hyperbolic x. What about sin hyperbolic x? E power x minus e power minus x by 2. So I will, for that purpose, I will adjust it 2 and then by 2. Okay. So what is that? A naught by 2 is 1 by a pi. This is the formula for sin hyperbolic x. Here replacing x by a pi. Therefore sin hyperbolic a pi. So what is the value of a naught by 2 here? 1 by a pi sin hyperbolic a pi. Okay. Now we can find out an. So an the formula is 1 by pi integral minus pi to pi f of x cos nx dx. So here also we can see f of x is e power x cos nx dx. Here we can use the Bernoulli's formula. No, we know particularly what is the Bernoulli's formula. Integral algebraic coefficient cos term, integral algebraic coefficient sin term. So generally we can use the Bernoulli's formula. But here this is exponential function, this is the trigonometric function. So we know that already the formula for integral e power x cos bx dx equal to e power ax by a square plus b square a cos bx plus b sin bx. So a is a, but b is n. So we can substituting here, replacing a by a and b by n. So we get the formula is equal to 1 by pi e power ax by a square plus n square a cos nx plus n sin nx. The interval is minus pi comma pi. The same manner we can using the substituting the upper value sin n pi. I will say again, sin n pi is 0, basic fact. Here also lower limit, I will using the minus pi. Sin of minus n pi, it's also 0. So in upper value, in upper using the upper limit here 0, lower limit 0. So I will cancel this term. So we can get this only one time. So we can using the upper limit here. 1 by pi is constant. Using upper limit x is pi. So e power a pi by a square plus n square, a cos n pi. Cos n pi is minus 1 power n. So we can get minus 1 power n. So lower limit, so the formula is minus. We can using the lower limit e power minus a pi by a square plus n square. We can using the minus pi. Cos of minus theta is cos theta, but sin of minus theta is minus sin theta. Here cos. So we can using the n pi. Cos of n of minus pi is minus. Sorry, cos of n of minus pi is cos n pi. Therefore, this also minus 1 power n. These two terms. So what is the common term? A and minus 1 power n. A and minus 1 power n. A by a square plus n square. These are all common terms. I will take an outside. Therefore, a minus 1 power n by pi a square plus n square. What is the remaining term? E power a pi minus e power minus a pi. So now we can separating these values. How do you? We know that already e power a pi by minus e power minus a pi. What is the sign hyperbolic x? E power x minus e power minus x by 2. So I will put here 2. Adjustment is 2. That 2 is here. 2a by pi minus 1 power n by a square plus n square. This is e power a pi minus e power by 2. That is sign hyperbolic a pi. So we can rearrange this formula. Steps. A n equal to 2a sin hyperbolic a pi by pi. Because of these are the constant term. This is the variable term for summation. So n is variable. So I will take and separating the n variable in left side. So for minus 1 power n by a square plus n square. That is a n equal to 2a sin hyperbolic a pi by pi minus 1 power n by a square plus n square. We can now find out the bn value. Bn the formula is 1 by pi integral minus y to pi f of x sin nx dx. This here problem is f of x is e power ax. So e power x sin nx dx. We now here don't use the Bernoulli's formula. We know already the basic formula. Integral e power x sin nx dx. This is the formula. Integral e power x sin dx dx equal to e power x by a square plus b square a sin bx minus b cos bx. So for the problem we can replacing here x a by a and b by n. So we get the formula here, this 1 by pi e power x by a square plus n square a sin nx minus n cos nx. Here a sin bx minus b cos bx. That is a sin nx minus n cos nx. Here the lower limit is minus pi and upper limit is pi. We can use the sin term. Upper limit we can using sin n pi is 0. Sin n pi is 0 and then using the lower limit minus pi. Sin n of minus pi is 0. So suppose the total term will be 0. The only remaining term is this. We can using the upper and lower limit for here this. So 1 by pi e power x by a square plus n square. We can using the upper limit pi here. That is minus n cos n pi. Cos n pi is minus 1 power n. Therefore minus n minus 1 power n. We can using the upper limit. The formula is minus. We can using the lower limit minus pi e power minus a pi by a square plus n square. Therefore minus pi is here minus n cos of n of minus pi. I already said that cos of minus theta is cos theta. Cos of minus n pi is again cos n pi. What is the value of cos n pi is minus 1 power n. Therefore minus n minus 1 power n. This step, the common term, what do you say the common term? Minus n minus 1 power n. Here also minus n minus 1 power n. A square plus n square, a square plus n square. These are all common term. I will take it outside. So what are the remaining terms? E power a pi minus e power minus minus a pi. This is the same formula, sine hyperbolic x. So sine hyperbolic x means, therefore by 2 we can introduce, you can introducing 2 here, therefore 2 by pi n minus 1 power n a square plus n square. This is sine hyperbolic a pi. Therefore by 2, so we can adjustment this 2 sine hyperbolic a pi. 1 by pi is constant, a square plus n square. This is 2 sine hyperbolic a pi. Here n is taken outside, minus of minus 1 power n, minus of minus 1 power n. We know that x power m into x power n equal to x power m plus n. Therefore we can adding the powers, x power m into x power n equal to x power m plus n. Here also same thing as minus 1 power n. Okay, so minus means minus 1 power 1 minus 1 power n. Therefore minus 1 power n plus 1. Therefore dn is 2 by pi sine hyperbolic a pi minus 1 power n plus 1 into n by a square plus n square. These are the constant term. This is the variable term for summation. Finally, we can substitute all values of a0, an and bn formula. So this is the result. We can this is the what is the common? 2 sine hyperbolic a by pi. This is 2 sine hyperbolic a by pi. 2 sine hyperbolic a by pi. We can take an outside. The remaining integral put on inside here. So 1 by 2a. 2 sine remaining is 1 by 2a plus a is summation minus 1 power n by a square plus n square cos nx. We take what is the common? We take this. So remaining term is minus 1 power n plus 1 by sin nx by a square plus n square. This is the Fourier series. The interval minus pi comma pi. Function is e power ax. Okay. Thank you. Thank you.